In order to determine the resultant internal loadings in the beam at cross section through point D and point E, we can utilize our method of section by making a cut at point D and E and exposing the internal loads, that is our normal force, the shear force, and the bending moment. Now, in order to do that, we first have to identify the support reactions. Here, I have a roller at point C that will have one support reaction going vertically upward as the motion is restricted along the vertical direction, whereas point A is fixed in the wall. That's why we have three support reactions of horizontal AX, vertical AY, as well as MA, as the rotation is also restricted at that particular location. Now, to do that, here we can look, I have four unknowns, whereas in a two-dimensional case, I have three equilibrium equations. So I won't be able to solve this thing if I draw our free body diagram for the whole thing. So we can divide this compound beam from section A to B and develop our free body diagram. Now, in this case, I have at point A all the three support reactions. Then the distributive loading can be converted into point load by multiplying our 2 kilopounds per foot times 10 feet, and that gives us the value of 20 kip that will be acting in the center of that distributed loading, where the centroid of that rectangular section act. Next, I have point B that is pin connected. So we have two support reactions of Bx and By. Now keep in mind, these are the internal reactions. So if we develop a free body diagram for section from B to C, they will have the same magnitude but opposite direction. And the idea is once we connect these two sections back together, those two forces will cancel out. Now, from on section B to C, I have a point load of 16 kip acting at point E, whereas I have a support reaction at location CY going vertically upward. Now, once we have developed the free body diagram of the two sections, let's go ahead and apply our equilibrium equation for each one of those sections. I'm going to start with section B to C as I have less number of unknowns in that particular free body diagram. So to start, we can go ahead and apply summation of forces along the horizontal x direction. In this case, I have only one force acting along the x direction, so Bx is equals to 0. Whereas if we add all the forces in the vertical y direction, we have By going downward, 16 kept going downward, and Cy going in the upward direction. Here we have two unknowns, so let's give it a number and let's go ahead and solve for our third equilibrium equation, that is summation of moment. I'm selecting at point B, that will eliminate our Bx and By. So we have just 16 kip having a moment arm of 8 that is going to create our clockwise moment, whereas Cy having a moment arm of 16 feet is going to create counterclockwise moment. Simplifying, we get our value of Cy as 8 kip. Now we can go ahead and plug that value back in equation 1 and solve for By, that is coming as negative 8 kip. Now, once we have these two values of Cy and By, we can go ahead and now move to our free body diagram from section A to B and start applying our equilibrium condition, since in that case now I have only three unknowns. So let's go ahead and start with our summation of forces along the horizontal x direction equals to 0. In this case, again, we have just one unknown ax. Bx value is already 0, so the value of ax is coming as 0 as well. Next, I can do summation of forces along the vertical y-axis, taking upward as positive. Here, ay is pointing upwards, that's why it's positive. 20 kip is going downward, taken as negative, whereas By is pointing upward. However, the magnitude is negative 8. So I'm just going to add the negative 8 in this case. Resultant value of Ay is coming as 28 kip. Finally, we can apply our third equilibrium equation, that is summation of moment. I can select any point on the beam, but I'm going with point B. So to do that, I have 120 kip that's acting downward, having a moment arm of 5 feet, that is creating our counterclockwise moment, whereas AY pointing upward is going to create our clockwise moment, having a moment arm of 10. Finally, I have MA, that is our couple moment, so that is added there as well. Simplifying, we are getting the value of the moment as 180 kip fit. Now, once we have all the support reactions, now we can move forward towards figuring out the internal loading, and we can start with point D first. Now, to do that, the idea is we have to make a cut at point D and analyze any side of the beam. I can analyze from A to D or from D to C. So in this case, I'm going to go ahead and develop the free body diagram for the section A to D here. Again, at point A, we have our two support reactions. AX value is 0. So AY is 28 kip going upward, and I have our couple moment of 180 kip fit that is acting in the counterclockwise direction. Whereas I have a distributive loading here acting off 2 k per fit, but the distance from A to D is 5. So we can convert it into a point load coming as 10 kip acting downward in the middle of the section AD. That will be 2.5 feet from point A, same case 2.5 feet from point D. Now, next we have to expose the internal loads. Since we have made a cut at point D, I have a normal going horizontally towards the right, the vertical, that is a shear force acting downward, and then I have our moment MD that is going in the counterclockwise direction. So this is the sign convention that we use if we pick a side of the beam that is on the left hand side of the section here. So let's go ahead and now apply our equilibrium equation, that is summation of forces acting along the horizontal direction equals to 0. We have just one normal acting in the horizontal direction, so its value is equals to 0 here. Then we can go ahead and do summation of forces in the vertical y-axis. I have 28 kept going upward, 10 kept going downwards, and then I have the VD, that is the shear force acting at point D going downward. Simplifying, we get the value of the internal loading as 18 kip. Finally, I can do the summation of moment. My go-to point is always select at the section, and it eliminates the value of ND and VD. So I have that 28 kilopound making a moment arm of 5 that is going in our clockwise direction, so that's why taken as negative. I have my support reaction of moment of 180 in the counterclockwise direction, so that is added. And finally, I have that 10 kip force going downward, having a moment arm of 2.5 that is going to create our counterclockwise moment. Next, the MD is added, that is also going in the counterclockwise direction. Simplifying, we get the value of the moment at point D equals to negative 65 kip fit. Here, the negative sign is indicating that the direction is opposite to what we have shown on our free body diagram. Now, once we have that, let's go ahead and finally figure out the internal loadings at point E. Again, the process is the same. We can pick any section from either from A to E or from E to C. In this case, again, I'm going with a smaller section because it will be simpler to solve. So I have my section E to C. There is a 16 kip force acting just right to the E. So that is shown on the free body diagram, whereas our support reaction of 8 kip going in the upward direction. Now, once we have made the cut, the internal forces or the internal loading will expose at point E. Again, the normal going away, shown in this case towards the left, the shear force going upward, whereas the moment is now in the clockwise direction. Again, this is the sign convention. If we pick a beam section that is right side of the cut or the section that we have made. Finally, again, we are going to apply our equilibrium equation. Normal force is again coming equals to 0, whereas if we do summation of forces in the vertical direction, I have my shear at point E going upward minus 16 kip as coming downward plus 8. That gives me the value of VE as 8 kilopounds. Finally, I can do my summation of moment at the section at point E, taking counterclockwise as positive. So I have my internal moment of ME going in the clockwise direction. So that's why taken as negative ME. Next, the 16 kip won't create any moment as it's going through the point E, whereas 8 kip is going upward, having a moment arm of 8 and going to create our counterclockwise moment. Simplifying, we get our value of ME as 64 kip fit.